Okay, hypothesis testing. We're going to do two examples on hypothesis testing. I don't really give a lot of information, but just working with the basics so we understand what we're dealing with here. You're given the fact that the alternative hypothesis is that the proportion is not equal to 3/5. So if that's true, we would have to assume, conclude, that the null hypothesis is that the proportion is equal to 3/5. And because it's not equal to, we're going to do a two-dimension or two-direction hypothesis test here. So we're assuming a normal distribution, and where the value in the middle is 3/5. And we would go and standard deviations here. And we'd say, okay, we're doing a two-directional test with a significance level. We're going to assume 0.05. So the critical area would be 0.05. Now it's split over two directions, right? So that would be essentially out here and out here. Okay. Because it's split in two directions. So this Z alpha, this is actually Z alpha over 2, because it's half. That's alpha over 2. That's half of the area. It's two-directional test. So we need to look at our test statistic, which we're given in this problem. The test statistic is Z equals 0.78. 0.78 would be less than 1 standard deviation away in the positive direction. So here's our Z of 0.78. And basically, the question is our test statistic within bounds of our critical area, or is it out of bounds? Is it outside does it lie in the critical area? Well, visually we can see no, it's within bounds, it's within normalcy, it's not beyond the critical value. But what would this look like? What would the p-value be here when you have a test statistic of 0.78 and alpha of 0.05? Well, the p-value in a two-directional test would be technically the area shaded yellow. It's technically twice the area beyond Z, because you have to think about it as a two-directional test. So we can find the area beyond Z here, and then calculate the p-value. So we can do, we're not going to do a test in the calculator. We're not going to do a test on the calculator because, unfortunately, the way that this is done, if we're doing a Z test, well, it's a one proportion Z test. You need the X value, N size, and all that other good stuff. What we can do is look at the distribution, and we can look at the normal CDF to get the area between 0.78 and a very large number with a mean of 0 and a standard deviation of 1. Oh, and the wrong screen. Don't want to be in a screen when you do that. Let's just run these back. To get so 0.218. So this area right here is 0.21218. So the p-value would be twice 0.218, or roughly 0.44. So this p-value is 0.44, which again, it's the area of all this yellow. Our p-value in this case is definitely greater than alpha. If the p-value is greater than alpha, you fail to reject the null. So if the p-value is greater than alpha, we fail to reject the null. I mean, essentially saying we're close enough to this value to throw it away, even though we're not at that value, we're close enough to it to not throw it away. And that would be how you're approaching a problem like 19, because this is all just based on numbers and understanding the normal curve and understanding that the p-value is the area beyond your test statistic in whatever direction the test is. In this case, it's a two-directional test, so you have to multiply this area times 2. Number 20 is slightly different. You're given that the alternate hypothesis is that proportion is less than 2/3. So the null then must be that the proportion is equal to 2/3. Okay. The test statistic you're given is negative 1.89, and alpha again is 0.05. Okay. Let's sketch this. So again, a normal distribution. Wow, that's really bad. I think I would get better at this. I think I actually get worse. 2/3, and we're only one directional test because it's this less than sign is one direction, so we're just going to consider one direction. This would be -1 z-score. This would be -2 z-score. So this -1.89 would be somewhere right here. That's our z. Our critical area, our z alpha, has an area of 0.05, which is going to be somewhere close to z, right? Is it to the left of it? Is it to the right of it? Let's find out. This is actually really close. So we're gonna need to compare our z alpha to the z, or another way to think about it, find the area to the left when z is less than -1.89. So what's the probability that z is less than -1.89? That's the area under that curve. So again, we're going to use normal CDF. But this came from -infinity to -1.89, and then all the good stuff, 1 and 0. So normal CDF, we're going to go lower bound of negative. I need to use a negative number, or negative button, large negative number, upper value of -1.89. So I'm going to go up to that value of -1.89. Mean of 0, standard deviation of 1. 0.0293. So actually this orange area is 0.0293. We compare that. So in reality, this z alpha is about here. So that tells us that our test statistic is out of bounds. It's outside into the critical area, because the p-value is less than alpha. We're going to reject that null hypothesis, because p-value is less than alpha, which is another way of saying that this area to the left of this test statistic is smaller than the area of the critical value, which implies if that area is smaller, then the test statistic is inside that critical area. That's why we can make a statement like this, basically just comparing the p-value to the alpha significance level. So there's two base examples on hypothesis testing. So I'm going to go through two other ones that are specific problems. Get a little bit more in depth.